Now the trigonometric function sine of x is certainly not a one-to-one function. We see its graph here on the left, and it's an infinite wave, and it certainly doesn't pass the horizontal line test. So in order to create an inverse sine function, we have to restrict its domain, and we define this piecewise defined function called the restricted sine function. So f of x is sine of x for x between minus pi over 2 and pi over 2, and otherwise it's undefined. We see the graph of this restricted sine function on the right, and its domain is all x values between minus pi over 2 and pi over 2, and the range is from minus 1 to 1. And of course, it does pass the horizontal line test because no y value is repeated in that interval of x values. The restricted sine function is one-to-one, and thus it has an inverse. So here we show the inverse in red and the restricted sine function in blue. And we call this new function sine inverse, indicated in this way. It looks like sine to the power of minus 1, but it shouldn't be confused with 1 over sine of x, and we also call it arcsine of x. We know a lot about this function just from its definition. Its domain is equal to the range of the restricted sine function, so the domain of sine inverse is a set of numbers between minus 1 and 1. And its range is the domain of the restricted sine function, so the range of sine inverse is a set of angles between minus pi over 2 and pi over 2. Now recall the two equations that relate f inverse of x and y. We know that f inverse of x equals y is the same as saying that f of y equals x. And in this particular case, that means that sine inverse of x is y if sine of y equals x, but because we're talking about the restricted sine function, we must also specify that the y is between minus pi over 2 and pi over 2. And then we have our cancellation equations. F of f inverse of x is x, and f inverse of f of x equals x. In this particular case, they translate to sine of sine inverse of x equals x for any x value between minus 1 and 1, but sine inverse of sine of x is x only for x between minus pi over 2 and pi over 2. That is, x actually in the domain of the restricted sine function. From the graph of sine inverse of x, we can tell it's an odd function. Sine inverse of minus x equals minus sine inverse of x. How might we evaluate sine inverse of minus 1 over the square root of 2 using our graph? Well, let's scroll back to our graph. Here we have the restricted sine of minus pi over 4 is minus 1 over the square root of 2. And when we draw the graph of the inverse function, these two coordinates get switched, and we have the point minus 1 over the square root of 2 minus pi over 4 is on the graph of sine inverse, which is the red graph here. So therefore, sine inverse of minus 1 over the square root of 2 is equal to the y value here, which is minus pi over 4. Now, obviously, we don't want to draw the graph every time we evaluate, so we can also use our algebra to evaluate sine inverse. So to find sine inverse the square root of 3 over 2, let's call that y. And saying sine inverse root 3 over 2 is the same as saying that y is an angle between minus pi over 2 and pi over 2, with sine of y equals the square root of 3 over 2. So this is what we introduced way back in our first lecture on inverse functions. F inverse of x equals y is the same as saying that f of y equals x. And because we're talking about the restricted sine function here, we have these bounds on the values of y. Now we can consult our unit circle if we like, and we're looking for an angle between minus pi over 2 and pi over 2 with a sine value of the square root of 3 over 2. And we see here that that angle, there's a unique such angle, that's pi over 3. So therefore sine inverse the square root of 3 over 2 is pi over 3. Now to find sine inverse minus the square root of 3 over 2, we can use the fact that sine inverse is an odd function, and sine inverse of minus x is minus sine inverse of x. So sine inverse minus the square root of 3 over 2 is minus sine inverse the square root of 3 over 2, which is minus pi over 3. Or you can also go through this process, look for an angle on your unit circle where sine of y equals minus the square root of 3 over 2, and that angle is between minus pi over 2 and pi over 2. You'll find that the angle you're looking for is minus pi over 3. Now let's work a little bit with these equations. F inverse of f of x equals x and f of f inverse of x equals x, keeping in mind our restriction on angles here. The one problem we might get into here is calculating f inverse of f of x, because remember sine itself is defined outside of the set of angles between minus pi over 2 and pi over 2. So the best way to approach sine inverse of sine of pi is evaluate from the inside out. So sine of pi is 0, but sine inverse of sine of pi is sine inverse of 0. It's that unique angle between minus pi over 2 and pi over 2 with sine of theta equal to 0, which is 0. So we must be very careful. We don't always have sine inverse of sine of x equals x. Evaluate cosine of sine inverse of the square root of 3 over 2. Well, here we should first evaluate sine inverse of the square root of 3 over 2. We saw above that that's pi over 3, and now we apply cosine to it, so we have cosine of pi over 3, which is 1 over 2.